Welcome to the first module of the Real-World Ethical Hacking course, Advanced AS7. In this series, we are going to learn how to hack like real hackers. That means hacking in an advanced way, but also hacking stuff that's actually used in the real world by people who know what they're redoing. And we'll use tools that real hackers would actually use too. This is not a beginner's course. If you haven't already completed the introduction to ethical hacking or have no experience in networking, then this course won't be for you. But if you do know your way around a network, then I am sure you will enjoy this course. In this first module, we'll focus on networking fundamentals, which is one of my favorite topics. I'm so excited to dive into it with you. In particular, we'll talk about key networking devices, packet switching versus circuit switching, and finally NAT and PAT. By the end of this module, you'll be able to configure all these concepts yourself and can move on to more exciting stuff later in the series. Let's get started. So here's a list of some important networking terms and technologies. We are going to go through them all and figure out what they mean. First off, we have hub, switch, router, bridge, repeater, modem, and firewall. These are all networking devices, but they are not created equal. Let's put them into two groups. On the left side, we have hub, switch, and bridge. These devices allow computers to connect to each other. They are called multi-access or MAC layer switches. On the right side, we have routers, repeaters, and firewalls. These devices connect different networks together. They are called multi-protocol or network layer switches. To be fair, firewalls can also act as a multi-access switch, but that is not their main function. We'll start with hubs. A hub is just a glorified extension cord with multiple Ethernet ports. All the computers connected to it basically connect directly to each other. There's no intelligence in a hub. It simply broadcasts whatever it receives to all its other ports except the one it received it from. Now when a computer sends data to another computer on the same network, it needs to know that computer's IP address. Since all the computers connected to the hub have direct access to each other, they all know each other's IP addresses. That means there is no IP hiding or translation happening. This is an example of what is called a broadcast domain. A broadcast domain is a group of devices that can reach each other by simply knowing each other's IP addresses. This concept is important and we'll come back to it later. Next up, we have switches. Like hubs, they connect computers to each other, but unlike hubs, they are much smarter. Each port on a switch has its own MAC address. So when a device connects to the switch stores the MAC address in a table. This table maps the MAC address to the device it is connected to. So whenever a computer wants to send data to another computer, it simply tells the switch where the other computer is and the switch makes sure the data gets delivered. Switches allow us to create multiple broadcast domains because each switch is a boundary between the broadcast domains. The only thing that needs to be configured is to make sure that the IP subnets match. Moving on to routers. Unlike switches, routers do not care about MAC addresses. Instead, they read the destination IP address in the packets. Every time a router receives a packet, it consults its routing table. The routing table is kind of like a map telling the router where all the other networks are. Using this map, the router can decide where to forward the packet next until the packet reaches its final destination. You might notice that in my diagram I have the router outputting to the same network it's reading from. This is usually not a problem. Routers typically have default routes that tell them to send any traffic it does NT know what to do with to a default gateway. Sometimes, however, you might see weird behavior if the default route points to the same network the router is connected to. That's why I keep the connection going to the default gateway hidden in this example. When you want to connect a router to the internet, you can replace the default gateway with an ISP-provided router. Now let's talk about bridges. Bridges are like switches, but instead of connecting computers on the same network, they connect two different networks together. This is useful if you want to connect two physically separate networks, but you don't have a router at that moment. In fact, you could even use a switch as a bridge by putting two ports into a trunk port mode. Next up, we have repeaters. Repeaters are similar to hubs in that they simply broadcast everything they receive to every other device they are connected to. However, before doing so, they amplify the signal to make it stronger. This allows them to extend the range of a network. The downside of repeaters is that they do not filter out malicious traffic like hubs. Finally, we have firewalls. Firewalls protect networks by filtering out unwanted traffic. To do this, they have rules that determine what traffic is allowed and what is blocked. For example, you could have a rule that blocks all incoming traffic unless it is initiated by a specific application. Firewalls come in many shapes and sizes. One type is a packet filtering firewall, which examines each packet individually. Another type is a stateful inspection firewall, which keeps track of the state of the connection. This allows the firewall to filter out traffic based on the context of the connection. Now let's talk about two ways of switching: packet switching and circuit switching. Packet switching is the most common type of switching. In this method, messages are broken down into small pieces called packets. Each packet is sent independently of the others. Packets can take different routes and may arrive at the destination out of order. The receiver is responsible for reassembling the packets and discarding duplicates. The advantage of packet switching is that it is efficient. Packets can be sent and received concurrently, and the receiver can process the packets as they arrive without waiting for the entire message to be sent. The disadvantage of packet switching is that it is less reliable than circuit switching. Packets can get lost or arrive out of order, and the receiver must handle these errors. Circuit switching is a more traditional method of switching that is used less frequently today. In this method, a dedicated path or circuit is established between the sender and the receiver before any data is sent. Once the circuit is established, data can flow through it continuously. This method is more reliable than packet switching since the entire message will either be delivered successfully or not at all. However, the overhead of establishing a new circuit for each message can be significant. Also, if one part of the circuit fails, the entire connection will fail. Because of these inefficiencies, circuit switching is less popular than packet switching today. Now let's talk about NAT and PAT. NAT stands for Network Address Translation and PAT stands for Port Address Translation. They are very similar technologies that serve the same purpose. They hide the internal IP addresses of a network from the outside world. This is important for security because it prevents attackers from launching direct attacks against the internal network. NAT and PAT also allow multiple devices to share the same public IP address. This is important because the number of available IP addresses is limited, and most organizations have more than one device. The way NAT works is simple. When a device inside the network tries to communicate with a device outside the network, the NAT router translates the internal IP address to a public IP address. This allows the communication to take place as if the devices were on the same network. Similarly, when a device outside the network tries to communicate with a device inside the network, the NAT router translates the public IP address to an internal IP address. This allows the communication to take place as if the devices were on the same network. There are two types of NAT, static and dynamic. Static NAT is when the same internal IP address is translated to the same external IP address. This is useful for servers that have a fixed external IP address. Dynamic NAT is when the external IP address is shared by multiple internal devices. This is useful for clients that need to communicate with servers that do not have a fixed IP address. PAT is similar to NAT, but instead of translating IP addresses, it translates ports. This is useful for applications that use the same IP address but different ports. For example, you could have two web servers running on the same IP address. With PAT, you could have the first server listening on port 8080 and the second server listening on port 8443. This allows both servers to be accessed from the outside network without conflicting with each other. Alright folks, that's all I got for this module. Now go out there and practice what we learned today. You can do this manually or with a tool like Cisco Packet Tracer or GNS3. To practice manually, open up your router's IP, which is usually 192.168. 0.1 and look for settings related to NAT and DHCP. To practice with Packet Tracer or GNS3, you can download them from their respective websites. Once you've downloaded and installed them, follow along with this tutorial video I prepared for you. Thanks for watching and I'll see you in the next module.